Hello everyone, welcome to Indian National Junior Science Olympiad 2012 Physics Solutions. Hello everyone, welcome to Indian National Junior Science Olympiad 2012 Physics Solutions. A load is to be moved using a wheelbarrow. The total mass of the load and wheelbarrow is 60 kg. The magnitude of gravitational acceleration is 10 meter per second square. What is the work done if the handle is raised by 50 centimeter? Given total mass of the load and the wheelbarrow is 60 kg. Weight of the system, that is mg, is 600 Newton. When the handle is raised by 50 cm, the center of gravity rises by h. Applying the properties of similar triangles, you can see h by 50 equal to 70 by 120, from which we get h equal to 350 by 12 cm. So work done W equal to mgh, that is 175 joule. In the process of electrostatic induction, a conductor is rubbed with an insulator, a charge is produced by friction, negative and positive charges are separated, electrons are sprayed on the object. In the process of electrostatic induction, a charged object is brought nearer to an uncharged object. So the charged object attracts opposite charges from the uncharged object. So in the uncharged object, negative and positive charges will be separated. So the correct option is C. A spherical convex lens of diameter 0.1 meter and power 3 diopter is used to produce the image of a candle flame kept at 0.4 meter from the lens in two different methods as shown in figure. Method A, 5 cm diameter of the lens is covered at the center with dark paper and the periphery of the lens is clear. Method B, 5 cm at the center of the lens is clear and the periphery is covered with dark paper, while the distance of the flame is kept same. What difference you see in the image formation? Let us see the analysis in the next frame. Let us see the definitions of paraxial and peripheral rays. Paraxial rays are those light rays which are close to principal axis. These rays converge at a large distance from the lens. Peripheral rays are those light rays which are far away from the principal axis. These rays converge at a smaller distance from the lens. So the image formed in method A is at a larger distance from the lens than the image formed in method B. A direct current motor is connected to a battery by means of two leads. The motor moves for slightly less than half cycle and comes to halt. Which of the following components is missing? See the diagram of a motor. Carbon brushes act as a sliding contact between the stationary wires and rotating armature. So slip rings are part of AC motor or generator. Split ring commutator reverses the direction of current flowing through the coil for every half cycle, so that the torque on the coil acts always in the same direction. So in this case, since the coil comes to halt after traveling half cycle, so the commutator is missing. A student connects two lamps in the circuit as shown. The EMF of the two batteries is different. Which of the following statements are correct? When keys 1, 2, 3 and 4 are closed, bulbs A and B will both glow. When the key 2 and 4 are closed, bulb A will glow. When 1 and 4 are closed, bulb A will glow. When 2, 3 and 4 are closed, both A and B will glow. See the circuit diagram carefully. When all the keys are closed, B is shorted by key 2. When 2 and 4 are closed, A will glow. When 1 and 4 are closed, A will glow. When 2, 3 and 4 are closed, B is shorted by 2. So the correct option is D. A is a tank filled to its 75% with water B is a weighing balance and C is a stone hung from a stand. If figure 1 is correct, what do you expect to be the position of the needle in figure 2? When the stone is dipped in water, its effective weight decreases due to upward buoyancy force exerted by water. So the scale reading decreases. The second scale reads weight of water and buoyancy force. So the scale reading increases. So the correct option is C. A transistor based radio receiver set, effective resistance of the order of 18 ohm, operates on a 9 volt DC battery. If this battery is replaced by a DC power supply with rating 9 volt 500 milliampere, then effective resistance of the transistor are equal to 18 ohm. Voltage of the battery is 9 volt. Current through the circuit is 500 milliampere. Rating of the power supply is 9 volt 500 milliampere. As the current rating of the power supply is equal to the current through the circuit, the receiver will work normally. A vibrator generating a wave on the surface of water. An object X is floating on the surface. Which of the following graphs of the floating object is correct? When a vibrator is generating a wave on the surface of water, the so generated waves will be transverse waves. The object floating on the surface of water will oscillate up and down in simple harmonic motion. So the velocity of simple harmonic oscillator V equal to A omega sin omega t, which is represented in graph 2. So the second option is correct. A ripple is created in water. The amplitude at a distance of 5 cm from the point where the ripple was created is 4 cm. Ignoring damping, what will be the amplitude at a distance of 10 cm? Let the amplitude of the wave be A. Intensity of wave is directly proportional to square of amplitude. So we can write I1 by I2 equal to A1 by A2 whole square. Intensity is power by area. So P1 by A1 by P2 by A2 equal to A1 by A2 whole square. Since there is no damping, P1 equal to P2, so we can write A2 by A1 equal to A1 by A2 whole square, small a representing area and capital A representing amplitude. Since R1, R2 values are given, we get A2 equal to 2 root 2, that is root 8 centimeter. The circuit given below for the operation of an industrial fan. The resistance of the fan is 3 ohm. The regulator provided with the fan is a fixed resistor and a variable resistor in parallel. Under what value of the variable resistance, power transfer to the fan will be maximum. The power source of the fan is a DC source with an internal resistance of 6 ohm. Here we need to apply maximum power transfer theorem. Power transfer to the fan will be maximum when the internal resistance of the battery is equal to total external resistance. So 6 equal to 6R by 6 plus R plus 3, from which we get a variable resistance value as 6 ohm. A submarine is floating in water half submerged in position A. It is then lowered to position B, where it sits for a while. Later, the submarine is taken to a position C and submarine waits there before it is finally taken to rest position at the bottom of the sea, which is position D. Assume that the density of water and value of G is same everywhere. Which of the following is correct for buoyancy force at the four places? Buoyancy force is volume of liquid displaced multiplied with rho liquid into G, where rho liquid is density of liquid. Given rho liquid and G remain constant, so buoyancy force is directly proportional to volume of liquid displaced. In position A, VL equal to V by 2. In positions B, C and D, volume of liquid displaced is equal to volume of the submarine itself. So option A is correct. 10 grams of ice at minus 10 degrees centigrade is added to 10 gram of water at 85 degrees centigrade. What is the final temperature and amount of ice left in the system? The system is kept inside an ideal insulator. Heat energy released by water when it cools down from 85 degrees centigrade to 0 degrees centigrade, Q equal to ms delta T, which is 850 calorie. Heat required for ice at minus 10 degrees centigrade to become water at 0 degrees centigrade, Q dash equal to ms delta T plus ml, that comes out to be 850 calorie. So the amount of heat available is equal to the amount of heat required. Ice melts completely to become water at 0 degrees centigrade and hot water cools down to 0 degrees centigrade. So the final temperature of the mixture is 0 degrees centigrade and no ice is available. The diagram shows a lift system in which the elevator of mass m1 is partly counterbalanced by a heavy weight of mass m2. At what rate does the motor provide energy to the system when the elevator is rising at a steady speed v? The steady speed at which the elevator rises is v. Rate of energy provided, that is equal to rate of work done, is equal to power. Rate of work done against gravitational force is m1 gv. Rate of work done by the gravitational force is m2 gv. So the net rate of work done is rate of energy provided by the elevator, which is m1 gv minus m2 gv, that is m1 minus m2 of gv. When all resistances in the circuit are 1 ohm each, then the equivalent resistance across the points A and B will be. The given circuit can be redrawn as shown in figure. Effective resistance between A and C is R by 3, that is 1 by 3 ohm. Effective resistance between C and B is 0 because there is a conducting wire connected between C and B. So the effective resistance between A and B is 1 by 3 plus 0, that is 1 by 3 ohm. A cathode ray oscilloscope is a device which converts electrical signals into an active graphical representation on a fluorescent screen. The x-axis is always time axis, where 1 centimeter is equal to a present time scale called time base. A sound wave is displayed on the screen of cathode ray oscilloscope. The time base of CRO is set at 2.5 millisecond per centimeter. What is the frequency of the sound wave? Time base of the CRO is 2.5 millisecond per centimeter, that is 2.5 into 10 power minus 3 second per centimeter. The sound wave completes one cycle in 4 units. So the time period is 4 into 2.5 into 10 power minus 3 seconds. So the frequency of the sound wave is reciprocal of time period, which comes out to be 100 Hz. A ball is released from rest above a horizontal surface. The graph shows the variation with time of its velocity, not to scale. The scale on the graph is changed at every impact. A, B, C, D and E represent areas. Which of the following are correct? Area under velocity time graph gives distance. For B, height reached by the ball after first impact is h1. For C, height of the fall of the ball before second impact is h1. For D, height reached by the ball after second impact is h2. For E, height of the ball before third impact, that is h2. So C is the correct option. A network consists of two ideal and identical voltage sources in series and a large number of ideal resistors. The power consumed in one of the resistors is 4 watt when either of the two sources is active and other is replaced by a short circuit. The power consumed by same resistor when both sources are simultaneously active would be: power consumed in the first case, P1 equal to E square by R, that is 4 watt. Power consumed when the cells are in series, P2 equal to E plus E whole square by R, that is 4 times E square by R, which comes to be 16 watt. Power consumed when the cells are in series opposition, P3 equal to E minus E whole square by R, that is 0 watt. As the two cells are identical, their EMFs are equal, so when they are connected in series opposition, the resultant voltage will be 0. Ice exists at minus 20 degrees centigrade up to a height h equal to 10 centimeter in a uniform cylindrical vessel with no air gaps. Water at a temperature x degree centigrade is filled in another identical vessel up to the same height h equal to 10 centimeter. Now, water from second vessel is poured into the first vessel and it is found that level of upper surface falls through h equal to 0.5 centimeter when thermal equilibrium is reached. Neglecting thermal capacity of the vessels, change in density of water due to change in temperature and loss of heat due to radiation, calculate the initial temperature x of water. Use density of ice to be 0.8 gram per cc. Let A be the cross-sectional area of the vessel. Initial condition: 10 plus 10 into A equal to mass of ice by 0.8 plus mass of water by 1. That is, we have equated volumes. Let the mass of ice melted is m. In the final condition, we have 19.5 A equal to mi minus m by 0.8 plus mw plus m by 1. From the above two equations, we have m equal to 2a. Applying principle of calorimetry, m ice s ice delta t ice plus ml equal to m water s water delta t water. Upon substituting the given numerical values, we have x equal to 24 degrees centigrade. A ball of mass 10 kg moving at 50 meter per second in northeast direction is forced to move at 10 meter per second in southeast direction in 10 seconds by the application of a constant force. Find the force vector. Initial momentum of the ball, P initial equal to m into V initial, that is 500 kg meter per second. In vector notation, P initial bar equal to 500 cos 45 I, 500 sin 45 j, that is 500 by root 2 I cap plus j cap. Final momentum of the ball, P2 equal to m into V final, which is 100 kg meter per second. In vector notation, we have 100 cos 45 I minus 100 sin 45 j, that is 100 by root 2 I cap minus j cap. Change in momentum delta P bar equal to P final bar minus P initial bar, that comes out to be minus 400 by root 2 I cap minus 600 by root 2 j cap. Time taken for change in velocity is 10 seconds. So force on the ball, F equal to rate of change of momentum. So delta P by delta T comes out to be 10 root 26 Newton. Tan theta equal to y component by x component, which is 1.5. So theta is at tan inverse 1.5, which is around 56.3 degrees with respect to positive x-axis. A microscope is constructed from an objective of focal length 1 cm and an eyepiece of focal length 5 cm. An object is placed 1.5 cm from the objective. If the final image is virtual 25 cm from the eyepiece, then Calculate the distance between the first image and the eyepiece. Calculate maximum possible angular magnification. Calculate the distance between the two lenses for this setting. Least distance of distinct vision for unaided eye can be taken as 25 cm. Let's go through the given data. Focal length of the object lens is 1 cm, eye lens is 5 cm, object distance is 1.5 cm, and image distance is 25 cm as it is given as least distance. Applying lens formula for objective lens, 1 by v minus 1 by u equal to 1 by f, from where we get v naught equal to 3 cm, that is distance of the image from objective lens. Applying lens formula for eyepiece, 1 by v minus 1 by equal to 1 by f, we have ue, that is object distance from eye lens, is 4.16 cm. The distance between the first image and the eyepiece thus is 4.16 cm. Let us proceed to the next frame. The angular magnification of an instrument is the ratio of angle subtended at the eye when using the instrument divided by the angular size without the instrument. Maximum angular magnification m equal to 1 plus d by f, that is image is at near point, which comes out to be 6. Distance between the two lenses L equal to V0 plus UE, that is 3 plus 4.16, that is 7.16 cm.